Hey guys, how are you doing? Today we're going to talk about a problem for the machine designs class in the College of Mechanical Engineering. This problem is about selecting a bearing. Before we're going to do this problem, we're going to have to know an equation that will help us select the bearing from the catalogs. Okay, I'm going to draw this box right here. This is the equation we want to use to select a bearing. You found that the shaft diameter should be 30 millimeters to achieve a fatigue factor of safety of 2 with the following variables: A equal to 410 millimeter, B equal to 460 millimeter, L equal to 510 millimeter, P, which is the force, equal to 5,000 Newton. Select a suitable bearings that will work for both locations below, and that will support the design load for at least 7 times 10 to the 7 cycles, which is the life of the bearing, at 1500 RPM from the bearing catalog attached. Okay, the catalog, which I have this link right here, I can also put in the description. When you click that, you will go to a web page, which looks like this. It has all the different specs and sizes, bearings, and particularly I highlight this part is because our particular problem has stated 30 millimeter right here, and with all this highlighted bearings that are all 30 millimeters, which right here, bore diameter, this is what we're looking for. I've done a screenshot for this, just this 30 millimeter ball bearings, which is on the bottom right here. You see right here. First of all, when you look at this problem, we can look at it as from static point of view. Let's draw a free body diagram. Let's say this is our shaft, where the force P right here, and reaction force, which is from the ball bearing, we call it R2. We call this R1, which is right here. R2, R1. This is the force. Okay. And we have distance A and B. Let's draw it right there. This is A. This is B. Yeah, you go to 410 millimeter. And we convert to a meter will be 0.41 meter. And B equal to 460 millimeter, which is 0.46 meter. And then we have the force pushing down, P equal to 5,000 Newton. So we set the moment at 0.1 will be equal to R2 times A minus P times B, and R2 equal to P B over A. Plug in the numbers, we have 5,000 Newton times 2.1 meter equal to 5,609.7 Newton. Okay. Now next we're gonna find reaction R1. So we had this is R2. We're gonna make sum of the force Y equal to 0. I'm gonna set it like this. X, Y. So that will be R1 plus R2 minus P, and R1 equal to P minus R2, which is equal to 5,000 Newton minus 5,609.75 Newton, equal to negative 0.75 Newton. Okay, the negative sign right here, it really just means that the direction of the reaction force is the other way, which we're predicting the R1 force is pushing up. In fact, the force actually is pushing down. This is what the negatives means. All right, so now we have P, we have R1 and R2. We're gonna use our bearing selection equations to find the bearing that's appropriate for application from the catalog. So now this is step that we're gonna select the bearing from the equations that we have. What we're looking for is FR, which is rated low from the catalog. That's how we select the bearings from the catalog. And FD is really R2, go to 5697Y. The reason we select R2 instead of R1 is because R2 has more load. So we plug in a number, LD, the life of bearing that we design, which is 7 times 10 to the 7 times LR. LR is the life of rated bearings in the industry. The standard industry number is 10 to the 6 times over 3, because the ball bearing that we have A equal to 3, and the number we have here is 23,120 Newton. Okay, now we go back to this list right here. We will select one of this. So at this one, this column is a static loading column, which is we want loading at least 5,600 Newton, which they all have it. Is good. And then the dynamic loading is right here, at least 23,120 Newton, 23,000. So we have this one and this one and this one. And depends on your applications, you can use any of the three, and this is our answer. We'll highlight this column right here.